Hi, Algebra 1 students. This is Mrs. Carroll again, and we are now on Project 6, Lesson 27. So we're getting close. We've got 6 problems to go through here, and all of them involve the same two-way frequency table. It involves another witness protection program participant. In this instance, an innocent witness, Javon, and his family are being placed in a witness protection program. Javon wants to move to a town where there are lots of other children for his kids to play with. The program officials have narrowed their placement options down to 2 towns, Shuffleton and Newchester. Use your knowledge of two-way frequency tables and statistics to determine which town is a better placement for Javon and his family. Okay, so for question 1, families in each of the 2 towns were surveyed and asked whether they have children. Of the families surveyed that have children, 18 live in Shuffleton, 14 live in Newchester. 10 families in Newchester and 21 families in Shuffleton do not have children. Create a two-way frequency table to organize this data. Okay, so let's go ahead and just plug those numbers in. So 18 with children live here in Shuffleton, and 14, live in Newchester. And so that's a total of 32 families that have children. This is going to be Shuffleton has 21 families without, and Newchester has 10 families without. So that's going to be 31. Okay, 32 and 31 give me 63. Okay, 18 and 21 give me 39. And 14 and 10 give me 24, 24. And just to make sure, these the 2 cells in the bottom add up to 63, and these 2 cells above should also add up to 63, so 39 and 24 add up to 63. Okay, so we should be able to add things in every direction for a frequency table. So 18 and 21 is 39, 14 and 10 is 24, 18 and 14 is 32, 21 and 10 is 31, 39 and 24 is 63, and 32 and 31 is 63. So if you can do all that, you know you've got your data right in a two-way frequency table. Now what you do with it is what's going to come up with the next couple questions. So this first question, what you actually have to enter is values A, B, C, and D in that order, and those are the joint frequencies. So let's just type those out, and this is how you do it, comma but no space, 18, 21, 14, and 10. All right, so that's our A, B, C, and D data. Let's go down, and I think I can make this just match up perfectly. So, okay. Now, the second question asks us to enter in the marginal frequencies, which are E, F, G, H, and I, in that order. So let's just type those in, separated by commas but not spaces. So 39, comma, 24, which we've already decided how we got each of those. We're just adding up the rows to get 39 and 24. To get 32 and 31, we're adding up the columns. And then to get 63, we're adding up both the bottom columns and the third row. So each direction, it adds up to 63, which is a good thing, because if it didn't, we would be incorrect here. Okay, so that is, those are the marginal frequencies. Let's scroll down. For question 3, using the table in the first question, okay, calculate the joint relative frequencies for M and N. So M is families that live in Shuffleton and have children. Okay, so what are the chances of that happening? So that is going to be having children and living in Shuffleton is 18. Okay, and and then the chances of that are 18 divided by 63. Okay, because 63 is the total number of families that were surveyed, and 18 of those total families that were surveyed live in Shuffleton and have children. So 18 divided by 63 and then times 100, because we're going to be entering this as a percentage. Okay, so when I do that math, 18 divided by 63, I get 0.285, which will round to 0.29, and multiply by 100 is 29%. Okay, and then we can do the same thing, families that live in Newchester and have children. So that is going to be 14 over 63 times 100. Okay, so 14 divided by 63 is 0.22, and that I'll just round that to 0.22 and multiply it by 100 to get 22%. So when you would enter this answer simply by typing 29%, comma 22%. Okay. And I'm going to erase these things here. I want to keep my frequency table data going with me. All right, let's go to question 4. And for question 4, we want to calculate the marginal relative frequencies for families that have children and families that do not have children. Okay, so this is going to be simply the total number, because we're not specifying the towns here. So we're going to look at the total number of families that have children, which is 32. Okay, so 32 families have children. That's point G there. Okay, it's the total of families that have children, divided by the total number of families, which is 63, and then multiplied by 100%. And when I do that, I get 32 divided by 63 is 50.7, so we'll round that up to 51. Okay, and then the percentage of families that do not have children should be 100 minus 51. It should equal 49%, because 100% of families were surveyed, 51% of them have children, so 49% of them should not have children. But let's just verify. Let's take 31 divided by 63 times 100%, and that is indeed 49%. Oops, forgot my 9. Okay, 49%. So when you enter that in, you'll want to just write 51%, 49%. Okay, that's number 4. We've got 2 more to go. Two-way frequency tables are pretty cool. They give you a lot of information to analyze. Okay. Now we need to find the conditional relative frequencies for R and S. So R is going to be families that have children given that they live in Shuffleton. So this is going to be the percentage of families in Shuffleton that have children. So the total that I'm dividing on this one by is 39. So 18 families in Shuffleton have children, divided by 39 total families in Shuffleton. Okay, for Newchester, it's going to be 14 families have children, divided by 24 total families in Shuffleton. All right, so let's do those calculations real quick. 18 divided by 39. So 46% of families in Shuffleton. So 46% in Shuffleton have children, and 58% of families in Newchester have children. So again, we'll type those answers in. 46% and 58%. Okay. So let's see. Last but not least, I think I can go ahead and just erase all these. Okay. Last question. If the Witness Protection Program is going to move Javon and his family to the town that has the higher percentage of families with children, which statistics should be compared? In which town should his family be placed, and why? Okay, so let's see. Here is what I would say to that. The conditional frequencies, let's see, we don't need this little bit here. The conditional frequencies, the conditional relative frequencies, found in the previous question are the best statistics to compare because they provide a ratio of the number of families with children in a town to the number of families in the same town. 58% is greater than 46%, so Newchester is a better placement for Javon and his family. So hopefully that makes sense to everyone. The other relative frequencies we calculated, we're either looking at just the total number of children to the total number, or the total number of families with children to the total surveyed. So they didn't take into account the town. That was for number 4. And for number 3, they were looking at the total in Shuffleton compared to the total number of families surveyed, and the total in Newchester compared to the total number of families surveyed. And that doesn't do us a whole lot of good because we want to know the total number of families with children in each community compared to the total number of families in each community. So that's why that the conditional relative frequencies for number 5 is the one that we want to look at. And Newchester's the town that they end up in. Okay, thank you so much.